Good afternoon and welcome to BIC's Office Hours. My name is John Kowalski. I'm part of the marketing team here at BIC and I'd like to welcome you. Today's topic will be about visual color evaluation. If you're unfamiliar with our Office Hours format, we'll have a shortened presentation, maybe 20-25 minutes, followed by open discussion and Q&A. So if you have any questions, comments, challenges with your own facility, please log them in the Q&A box located in the bottom right-hand corner of your screen. We'll get to them as soon as we can immediately following the presentation. Also, we are recording this, and in tomorrow's follow-up, we'll send not only the link to the recording, but also the presentation that our speaker will be going through. So look for that tomorrow morning in your email inbox. So with that, let me introduce Mr. Cohen. He is our Senior Applications Specialist and will be walking you through visual color evaluation today. So Corey, there you are, sir.
Thank you, John, and good afternoon, everyone. Thank you for joining us for today's Office Hours discussion on visual color evaluation. So we at BIC Gardner, spend a lot of time talking about color measurement instruments called spectrophotometers and the kinds of numbers you get from them and the different types there are and the different ways of measuring the different calculations. So those are our machines that will measure and quantify your color for you so that you can discuss color differences in numbers. That this color is this many units lighter, darker, redder, bluer, greener, or whatever. But sometimes it can be useful to evaluate colors visually. It can be useful because the goal of these spectrophotometers that we make and sell and use is to measure what we see. And so it's occasionally good to actually look at our samples, look at our different colors, and make sure that those readings that we get, the numbers that we get from our spectros are matching up with what we see. Also, spectrophotometers cost a little bit of money. And daylight is free, or office light, or whatever you might use to evaluate your colors. It's a lot cheaper to do visual evaluation, so that's another reason a company might decide to do visual evaluations over instrumental color evaluations. But really, the best way to do it is complementary to each other, to measure with a spectro and also to evaluate your colors visually to make sure that the numbers match up. So we're going to have just a brief discussion on visual color evaluation. Then, as John mentioned, we're going to follow that up with a question and answer session where you can present any questions that you may have lingering in your mind. So here we go. So visual perception is dependent on the light source, of course. So we have outdoor evaluation, which could be at noon when the daylight is a mostly whitish light source, or it could be done at sunset when the sunlight has sort of an orangish hue to it. So different times of day, even if it's the same light source outdoors, different times of day will provide different kinds of light that are going to cause our colors to look differently. And then, of course, we have indoor lighting, which are typically things like fluorescent lamps. They could be tungsten bulbs, less and less. More and more, we're dealing with LED light sources. So we also want to know what our colors look like under these indoor light sources as well, particularly for products that are going to be used indoors. You, of course, want to evaluate them under indoor lighting to make sure that your samples match your standard or that the color looks good. So color perception is influenced by the background. So not just the light source, but also the surrounding colors, the surrounding hues that are surrounding the color you're evaluating. So here we have some little pink boxes on the left and some little green boxes on the right. and they all appear to be somewhat different from each other. But the fact is they are actually all the same. It's just the surrounding colors, the ambient colors, that make these inside boxes look a bit different. So the surrounding color does influence our perception of the color we're evaluating. So for solid finishes, here are some tips for doing indoor color evaluations without a light booth. So evaluations are always preferably done with a light booth, but if you don't have one, we recommend trying to find a north-facing window. North sky daylight is kind of a standard for evaluating colors. So if you can find a north-facing window to provide the illumination for your samples, that's good. You want an uncluttered neutral surrounding for the reasons that you saw in the previous slide. You don't want to have chromatic colors surrounding the colors that you're trying to evaluate. You want it to be surrounded by neutral colors, meaning grays and whites and blacks. The specimens should physically touch each other. It is a lot easier to discern small color differences between two colors, between a standard and a sample, when they are touching each other than when there's a gap in between. So for color evaluation, you always want your samples, your specimens to physically touch each other. And you want the illumination and viewing conditions to be either 0-45 or 45-0, meaning if the light source is illuminating the samples from directly overhead, that's a 0-degree illumination angle. So you want to position yourself at about a 45-degree viewing angle off of that normal. If the light is coming in at 45 degrees, as we have here in this picture with the sunlight slanting in from outside the window, if the light's hitting at about a 45-degree angle, you would want to position yourself at 0 degrees or directly above the surface. So 45-0 or 0-45. But of course, the issue with doing things this way is that the light source is not constant. That the quality, the spectrum of that daylight, and the amount of that daylight is going to change depending on things like the time of day, the time of year, the geographical location. So if you have different plants who are all observing samples using natural daylight, they're going to see different daylight. Even if they do it the same day and the same time, different geographical locations will see different qualities of daylight. So there are a lot of things that can affect the light that you're using as a light source when you're using daylight as that light source. And so that light source is not constant. So here are some international standards for visual evaluation of solid colors. They call for certain standard illuminants, most commonly the D65 illuminant, which is meant to be representative of north sky daylight. But you'll also see some other daylight illuminants, D50, D75, and horizon light, which is that orangish light that you see when the sun is about to set. And then metamerism is evaluated under a number of other illuminants, the A illuminant, which is an incandescent illuminant. The F illuminant, F2 and F11 are fluorescent illuminants. So it's good to check samples for metamerism to make sure that they match under all lighting conditions or under several different lighting conditions. And we'll get into exactly what metamerism is in a little bit. The level of illumination, this is the actual level, how much light there is determined by the standard test method being used. The color of the interior, again, it's always a neutral color, but generally there's some type of defined matte gray that's used as a surrounding color for light booths. The gloss of the interior, and generally samples will be evaluated under diffuse light. So light booths are going to have a diffuser panel. So in order to really correlate with or conform to one of these standard test methods, it is necessary to use a light booth so that all of these conditions can be standardized rather than just using natural daylight. So metamerism is when you have a pair of colors, a standard sample pair that match under one or more illuminants, but do not match under another illuminant. So here we have a pair of colors. You can see on the left, they're a pretty much perfect match under daylight. If you look to the far right, I believe that's supposed to represent, TL84, that's a fluorescent bulb. And we can see under fluorescent lighting, this pair is also a pretty good match to each other. But if you look at these colors under incandescent lighting, under that tungsten bulb, they're a pretty significant mismatch. So this is representing metamerism. This is where two colors match under certain illuminants, under certain light sources, but not under others. And so this is why it's important to evaluate colors. If you're evaluating visually or even instrumentally, it's good to evaluate colors under different light sources, under different illuminants to make sure that they'll match wherever that product may be used, whether it's indoors or outdoors. And so this is why metamerism happens. So you have a sample standard pair, and their spectral reflectance curves are measured using a spectrophotometer. And we can see those curves here. We can see that even though these two colors appear to be a match under D65 daylight, they actually have different spectral curves, as we can see here. And so when two colors have different spectral curves, when they match but have different spectral curves, that tends to be an indication that those colors are going to be metameric. And one simple test for determining whether two colors are metameric just by looking at their spectral curves is by counting how many times they cross. So you can see that the curves cross here, they cross again here, and then they cross again back here. So they cross 3 times at least. And typically, if two colors, if their spectral curves cross 3 or more times, they're typically going to be metameric, which is true here as well, because even though they're a match under D65, they are not a match under the A illuminant. So this is another metameric pair. So CIE has standardized a number of different illuminants. Here we have 3 examples: D65, which again is north sky daylight. The A illuminant is meant to be representative of an incandescent bulb, and F2 is representative of a fluorescent bulb. So when we talk about illuminants and light sources, these are actually 2 different things. We tend to use them interchangeably, but the fact is they are different. Illuminants are basically just a set of numbers. An illuminant is a set of numbers that describes the spectral power distribution of a given light source. So it tells us for the D65, it tells us the relative power level of each wavelength in that D65 illuminant. But the illuminant is just that set of numbers. A light source is an actual physical object that gives off light. And so in order to create a light booth with all of these standard illuminants in it, we now have to create light sources whose spectra match the spectral power distributions of each of these illuminants, right? So for example, for A, this curve up top, that's the set of numbers that tells us how much of each wavelength is present in that illuminant. But now we need a physical light emitting object that can match that spectral curve. Well, fortunately, the A illuminant, the spectrum was just based off of an incandescent bulb, a tungsten bulb. And so that's pretty easy to recreate. You just take a tungsten bulb, pop it in your light booth, make sure that the the spectrum match is close enough, and you have your A illuminant. Similar to the F2 illuminant, that's a fluorescent illuminant. So this illuminant was based off of an actual fluorescent light source. And so in order to recreate this illuminant in a light booth, you just have to use that same type of fluorescent bulb. Where it gets really tricky is that illuminant to the left, the D65 illuminant, because D65, that's representative of sunlight. It's representative of the light given off by the sun. So it's very, very difficult to recreate that light source exactly because, whereas with the A and the F2, you can just use the appropriate bulb for that. There is no bulb that exactly recreates the light source given off by the sun. So that's a tricky one to try to recreate. And traditionally, it's recreated actually using filtered fluorescent tubes. So D65, if you look at the bottom there, that red curve is the actual D65 illuminant, and then the spiky black curve is what you actually get using a fluorescent light source for D65. So it's very tough to recreate exactly. So here are two of our light booths, the Bico Spectra Basic and Mini. They're pretty much the same, they're just two different sizes. The Mini is the smallest one. They each come with 3 illuminants. So you have that the daylight illuminant, the D65, which is recreated using that fluorescent bulb. You have the incandescent illuminant, the A illuminant, which is recreated using a tungsten bulb. And then you can choose between either CWF, cool white fluorescent, which is the F2 illuminant, or the TL84 bulb, which is the F11 illuminant for your fluorescent illuminant. So 3 illuminants in the basic and mini models. Easy operation. You have switches to turn on and off the different illuminants. And again, the difference between these two models, the basic and the mini, is just the size of the light booth. And go from there, we have our Bico Spectra Light and Bico Spectra Standard light booths, and these each come with 5 different illuminants. The D65A, both CWF and TL84, as well as a UV bulb to test for fluorescence. And one of the benefits of this level of light booth is that you can program it for automatic sequencing, which is good. So when evaluating colors in a light booth, particularly when evaluating metamerism, when you want to see if a pair of colors match under a number of different illuminants, you need to switch back and forth between those different illuminants. But it's better if you can evaluate the colors without taking your eyes off of them. So it's better to be able to switch the illuminant without removing your eyes from the samples, and the way you can do that here is with automatic sequencing. So you can automatically set up a sequence of illuminants, whatever order you want to see them, and it will automatically switch back and forth between them without you having to remove your eyes from the samples you're evaluating. And then that brings us to the Bico Spectra Pro. So this model uses a smart combination of a filtered tungsten halogen lamp and a set of supplemental LEDs. And it adds the right amount of UV light. You can actually turn the UV on or off when activating the D65 illuminant. So the benefit of this light booth is it actually has the most accurate D65, the daylight light source in the industry. So on the right here, we see the way D65 is typically recreated using these fluorescent tubes that have these big spikes. And this is a really, really rough approximation of the D65 illuminant, what you get with this light source. So this is a typical light booth. With the Bico Spectra Pro, it uses those halogen lamps with a supplemental LED array to more precisely recreate that D65 Illuminate. So here again on the left, you can see that red curve is the D65 Illuminate, the actual illuminant as described by CIE. The gray curve is the halogen lamp without the supplemental LEDs, and then the blue curve is the halogen lamps with the supplemental LED lighting. And so that blue curve more closely approximates that red actual D65 curve much, much better than the fluorescent lighting used in most light booths. And so the way this is evaluated, the quality or the closeness of the D65 Illuminance, it uses what's called a visual metamerism index. And what it does is you take a metameric pair, so this is a pair of colors that match perfectly under one illuminant but not under another. And so we can see this pair on screen here. And this is almost a perfect match. This is a very good match under natural daylight. And also under our Class A light booth, the Bico Spectra Pro, it's almost exactly the same as under daylight. It's a very, very good match here. But we can see that under fluorescent tubes, under the D65 lighting used by other light booths, the match isn't nearly so good. So this is how you evaluate the quality of the D65 Illuminance, how closely the two sides match under a given light source. And so you give it a class A, B, C, D, E, depending on the calculated color difference of the two sides under a given light source. And if that number is less than 0.25, it is considered a Class A light booth, which the Bico Spectra Pro is. So this is a fairly sizable light booth. You can see the interior dimensions up there at the top left. But this light booth can actually be used as a luminaire as well, meaning the booth part of it can actually be removed, and you can just hang the lighting part of it on top from the ceiling of your light room in order to evaluate colors, as you can see here, using two luminaires side by side, or you can create a whole array of them for a light room. So this is something that might typically be done by like an automotive manufacturer, so that they can view an entire car or some large part under a number of different illuminants, as you can see here. So some tips for evaluating colors when using a light booth. Again, you want to wear, you want neutral surroundings, but you also want to wear neutral colored clothing. That's important as well. If, for example, you're wearing, say, a very chromatic red shirt, you could have light reflecting off of your shirt and then onto a neutral surface. So rather than seeing that surface as neutral, you're actually giving it a reddish hue just from the reflection off of your bright red shirt. So it's important to wear neutral colored clothing as well when evaluating colors. You want no clutter inside the light booth. You really only want to have the two parts or the two samples that you're evaluating. Again, the specimens should physically touch each other. It's always easier to tell small differences between two colors when they're physically touching. Again, you want either 0.45 or 45.0 illumination and evaluation conditions. Since a light booth typically is going to have the illumination directly overhead of the samples, so it's going to be 0-degree illumination, you're typically going to be positioned in front of the light booth looking at the samples at a 45-degree angle. So typically with a light booth, it'll be 0.45. And another key component to evaluating colors visually is to make decisions quickly. And this is important because of an idea called color fatigue. So this is the last thing I'm going to talk about today. What I'd like you to do is we have this lovely image of an American flag, except it's not, because it is, of course, the wrong color. So I'd like it if you would look at the center of this flag and that white spot in the center. Just try to keep your eyes fixed there. We're going to go for about 20 seconds. Try to keep your eyes fixed in the center. Keep your eyes fixed there, and I'm going to switch. There you go. Now, for just an instant, did you guys see a red, white, and blue flag rather than the green and yellow flag? So the reason for that is color fatigue. So what happens is when we look at a particular color or colors for too long, our eyes actually get fatigued and our ability to see that color lessens, right? So when I have white on the screen, white is a neutral color. White is a mixture of all the different colors of light, right? So all the colors are in balance to make it neutral. So there's green and red in here, but there's just the right amount of green and red that it makes it neutral, and same with blue and yellow. So you end up seeing a white color, even though this is just a mixture of all the different colors. They balance each other out. So what happens when you look at this green and yellow flag for long enough, your eyes get fatigued. Your eyes get tired of seeing green and yellow, and so your ability to discern, your ability to see green and yellow becomes less, right? Now, what are the opposite of green and yellow? Blue and red, right? So when your ability to see one color is less, your ability to see the opposite color becomes greater. So when you go from this and you're getting fatigued from that green and that yellow, when you switch to white, all of a sudden your ability to see blue and red are greater than your ability to see green and yellow. And that's why you see that red and blue flag for just a few seconds until your eyes adjust. So that's color fatigue, and that's why it's important to make decisions quickly. When you're looking at two different colors that are similar to each other but might be somewhat different, the longer you stare at them, the more fatigued your eyes are going to become, and the less will be your ability to discern the small differences between those two colors. So when you're making visual color decisions, you want to look at them and make your decision within a few seconds and then move on. Okay. And that is all I have for you today as far as the presentation goes. So I'm going to toss things back to John for our Q&A.
Yeah, thanks, Corey. Good stuff as always, and lots of things to take into consideration from your viewing angle to what light source, to what you're wearing even, so that the reflection of the light doesn't impact how you're seeing things. If anyone has any Q&A questions, please enter them in the Q&A box located in the bottom right-hand corner of your screen, and we'll get to them. First question here, Corey. Do we need to calibrate the instrument, and how often do we need to do that? I assume that's talking about the light booth. Let me see here.
Yeah, you're referring to a light booth. So typically they will come with a certificate,
yes,
saying read with a spectroradiometer, and that the certain conditions, the lux levels and all that, the color temperature falls within the range as advertised for whatever light source it is. And typically most light sources are going to give a count. it's going to give you an amount of time that you can use each light source before it should be replaced. Typically, that'll be somewhere between 500 and 2,000 hours, I think, depending on the light source. But a lot of light booths will have an actual counter on it to tell you how long a light source has been in use, so that you know when to replace the bulbs. So it's generally more of a after a certain amount of time has gone by, or after the device has been in use for a certain amount of time, that's when you replace the lamp.
Okay, thank you. Got an unrelated question here. Someone's looking for the AutoMatch 4 spectrophotometer user manual. That should be available at byk-instruments.com.
It's not.
Instruments.com. It's not.
The website, yeah. Contact me directly, and I can help you out with that.
Okay. So you can reply to the email that you get with follow-up materials tomorrow, and that'll go to us in marketing, and we can get it to Corey. Or Corey's email is corey.cohen@altana, altana.com. And following the presentation too, if you have any technical questions, feel free to email him directly or respond to the email you get with us. Corey, do you get frequent questions when it comes to visual evaluation? If so, could you share some of those frequent questions with the listeners?
Frequent questions.
And same, anyone from the field too, feel free to chime in here while we're waiting for some other folks to log their questions. Quiet bunch today. Yeah, definitely folks listening. Oh, go ahead, Ray.
Okay, so a lot of times, like what we hear, I've seen, we've been in the field and they may have, like a blue wall at a customer. And when they look at that car against that blue wall, they get a different perspective. So, the surrounding color is huge, even if you're outside and maybe it's 10 feet away. So it's really important that everybody pays attention to the surrounding colors, and also the clothes you're wearing are really important. I know if I go to a color harmony, I would not wear like a red shirt, but if someone does have a red shirt on, we make sure they put on like a lab jacket to cover up that red, because that also changes your perspective. And another thing is, when you're especially, I'm talking automotive here, but it would work for anything. If you're looking at a different angle than somebody else, I know a lot of times on the vehicles, everyone kind of stands in a half moon. And you have to think, now you're all looking at different angles. So my perspective on, say, the left side of the half moon is going to be very different from if I'm standing on the right side of the half moon, and even the person in the middle. And also height variation is really important. So you need to be looking at the same angles all the time. So
yeah, I'm glad you mentioned the height variation, because I've heard you before in presentations, Ray, when you're looking at a car with a group of people, there's a lot of people taller than you. Their angle of viewing is definitely different than what you're seeing. Is there what standard?
What standard?
Or recommended angle?
It's not that simple, because depending on the time of year and where you are in the world, angle of the sun is different. But I can tell you, if I look at a vehicle and the guy next to me is 6 foot and I'm like 5'8", I'm going to stand on my tiptoes and try to look exactly at the same angle he's looking at, so that I have the same perspective. Or, if it's Geraldine, she's smaller than me, of course I'm going to bend down to Geraldine's level and see if I can see the same thing that she's seeing. Because people think it's not that important, but that angle of view is very important, because it can completely change your perspective.
Mm-hmm. Yeah, good point. Another question here. If the paint in the booth fades away, does it affect the visual evaluation?
Yeah.
Yeah, somewhat. The most important thing is that the surrounding be neutral. So if, the exact shade of gray is changing slightly, it's probably not such a big deal as if it were to, become yellower or something. So yeah, the neutrality of the paint or the surrounding on the light booth is important. But there are different standards, as you saw. So in this slide, there are specifications for the color of the interior that you can see here. And so like this one, this ISO method specifies the L value and that the A and the B value should be less than 1, which would make it a neutral color. These specify N6 or N7, which I believe are Pantone colors, Pantone grays. So if your light booth is old enough where it does start to fade, you can always repaint it one of these standard colors for light booths.
Okay. Good. Another question here from Christopher. How long should you approve colors before you rest? Approval process requires people to approve for long periods of time. I think that's getting to the fatigue.
So what do we say? Something like 5 seconds? You should make your decision within 5 seconds. Does that sound right to any of my colleagues on the line?
Yeah, I mean, I think like your first impression is probably the most realistic. If you have to stare at it, especially if it's a chromatic color, you're going to have super eye fatigue. And then things start to look wonky and you're not going to make a good decision. So, you look at all the angles, pretty much like Corey said. I mean, maybe 5 seconds, maybe 8 seconds, but yeah, not long. And then you make your decision and you move on.
Mm-hmm. Okay.
Like taking a multiple-choice test, they say your first impression is probably the correct one.
Yes.
Mm-hmm. Question here from Mike. How do you judge the color of cloudy solutions? And Mike, let me find you here in my list and unmute you here. There you are, Mike. Can you hear us? Yeah. Can you mind clarifying a little bit?
Yeah. So a lot of this is based on our experience with your LCS 4, I think, and it's a instrument that's designed to measure the color of transparent liquids. We're a QC lab, and we make a lot of liquid samples. But in the process, maybe of time, or maybe some other reason, there are solids in the solution. So do we spin them down? Do we filter them? But in the process, we have seen on occasion, we remove some of the color by removing the solids in that. And so I was just curious, in situations like that, what's the best way to characterize the color or the appearance of the sample?
So this is the venue. Anybody else on the show? I mean, I would think that you would want the cloudiness to be in there because when you use that material, it's going to make it cloudy, right? I mean,
and I agree completely. But the instrument that we have is geared for transparent liquids.
Yeah. McDonald, do you know?
Yeah, can you hear me?
Yeah, we can hear you.
Okay. The LCS instrument really is designed as a transmission-based spectrophotometer. It has to get enough light through the product. if it's too hazy, it's just going to scatter the light, and you're not going to get a reliable reading. So if it reaches that point of translucency where it's really more of an opaque than it is a transparent, you might want to get a thicker cuvette, maybe a square cuvette with a longer path length. Back it with, fill it with the product and back it with some known background like a white tile or something like that, and then turn it into a reflectance-based measurement. That's what I would do in one way or another. You might not get perfect colorimetric readings, but you'll get a pretty good relative color comparative reading.
And that's a good idea. Sometimes we do have a control, so customers interested in much as a comparison as they are in actual value. So that's a good idea. I'll have to look at the instrument layout. I get it what you're saying in theory. I'm just now trying to figure out how to do it in practice. But okay, thanks.
Sure thing.
All right, thank you, Mike. I'll put you back on mute here. Next question from Christopher. I think that viewing reds requires you to look at colors longer so that you can evaluate them easier. Would you agree? Christopher, let me unmute you here. Okay, you're unmuted, sir. Do you mind elaborating a little bit? You're welcome.
Yes, in automotive, we have lots of red colors. And what we've found more recently is that you need almost to look at a red color a little bit longer so that you can actually see the subtleties of whether it's slightly yellow or whether it's slightly too blue. And it seems to be a phenomenon that we've come across more recently, that you actually need to look at it for a little bit longer. I recognize that that's probably getting some fatigue, but it's almost as if it's like someone switched the lights on, it's all too bright, and then eventually your eyes adjust to the red, so your eyes almost become a little bit more relaxed looking at the red and able to see these subtle tones. I'm not sure if that's something that you've come across, but that's something that we have seen in the refinish industry.
So, I mean, I can take this one. Going back to my days when I used to color match, I think the biggest thing is that when you talk about, especially like really chromatic colors, that you always talk about hue, then chroma, then lightness, darkness. And if you kind of think in that way when you look at it, yes, of course, maybe you need to look at it a bit longer, or maybe you need to look at it, take a break, and look at it again, But those colors can still like super fatigue your eyes. Like yellows are horrible. If you look at it too and see, oh, I think it's blue, now I think it's not, whatever. I mean, you can come up with all sorts of different analysis depending on how long you look. So I would just think first you want to look at the hue, then the chroma, and then the lightness, darkness. And I think that might help when you're viewing colors like that. Does that make sense or no?
Yeah, no, you're right. I think it's a question that the saturation and the eye fatigue, there's probably a balance before you start misjudging the color because of the fatigue going on. So yes, thank you very much.
Yeah, you have to definitely watch that. Because, I can tell you, I've looked at stuff for too long and I've screwed stuff up. So I understand.
All right. Thank you, Christopher. Okay, next question here from Alexis. Are the fluorescent yellow vests we're required to wear at Harmony reviews affecting what we see?
Yes, they are.
Yeah.
And I know you have to wear them for safety reasons, and I understand that. The best thing I can tell you is maybe stand at least 5 to 10 feet away from the vehicle so that you're not reflecting off of your vest.
Alexis, I'm going to unmute you just for a second here. Does that help? Are you there, Alexis? We can't hear your audio, but if you need additional help, log it in the Q&A box and we'll get to it again here. Next one here from Clara. Does a color swatch need to show that it matches the standard under all 5 Illuminates in order to pass a quality check for automotive? Want me to repeat that one?
No, I got it.
Okay.
Technically, no. They usually look under horizon, fluorescent, daylight, and tungsten light. The only thing I can tell you is that what I've seen in automotive is if you go from daylight to fluorescent, sometimes when it has metamerism, like say I have a vehicle that looks good outside and then I put it in a showroom under fluorescent lights, then you can have an issue if there's metamerism. But I don't think, Corey, you don't think all 5 illuminants are not required, right? It's only 3 or 4.
You would know more about the specifics of the automotive than me, but that's, yeah, 5 successive.
Yeah, so I mean, normally they do F11, 10 degree. What's tungsten, Corey? C?
A.
A under 10 degree and D65 under 10 degree is normally what everybody looks at for metamerism, and some people look at it under horizon just because if you look at it later in the day, maybe the color's changing. But that's what I know.
Okay. Clara, I'm going to unmute you here. Does that help answer your question or give you some additional clarification?
Yeah, and I just wanted to clarify, when you say look at it under horizon, are you referring to another light source, or do you mean the angle that you look at it should be low, like a horizon?
No, another light source.
Okay.
So like on your light source, I think it's H, right? I mean, Corey, I'm not good with these things, but H, right, Corey? Is horizon?
Sounds D.
What?
H or HZ, I'm not sure which one it is.
I can't remember which one. It's one of those two, but so normally if a paint supplier or paint manufacturer is going to evaluate it, they do the ones I first said. And then the horizon is like an extra one.
Okay, got it.
Pretty much.
Thank you.
All right. Thank you. Okay, next question here, Romeo. When evaluating color for various angles, should the light source be fixed?
Yeah. So this would be related to effect pigments like you'd use in automotive and things like that, where the observation or the evaluation angle is very, very important because it's going to change depending on the evaluation angle. So yes, both when measuring effect pigments instrumentally and when using a light booth, the illumination angle is fixed and it's only the observation angle that's changing. We actually have a light booth called the Picospectral effect that's meant for effect coatings, and it's meant to be able to view panels at multiple evaluation angles. And the way that works is the sample table rotates so that the evaluation angle changes, but the light source actually rotates with it to keep the angle of the light source between the angle of illumination between the light source and the samples consistent. So yes, the answer is yes, the light source should be fixed and only the observation or measurement angle should change.
Okay, thanks, Corey. Another question in here from Tim. When comparing samples, is it better to have them side by side or one above the other?
Side by side.
Yeah, I think just because when you do top to bottom, like the the distance from your eye to the sample is changing depending on whether the sample is on the top or the bottom. The relation between the light source and the sample might be different. So yeah, side by side would be more consistent.
And the other thing too, sometimes it's good to swap them. You know, you have one on the left and one on the right, and then you take the one from the right and you put it on the left, and that sometimes helps you see a little bit more.
Okay, good stuff. Next one here, question here from Robert. Hold on here. Seem to have disappeared. Robert, do the same principles apply for viewing solid colors versus effect colors?
Mostly, solid colors are not as angle dependent. So like what Ray was talking about before, where different people are of different heights, you should either like stand on their tiptoes or crouch down to try to get the same angle. That's really only crucial for effect pigments. For solid colors don't really change depending on the evaluation angle. And so it's not going to be nearly as crucial as for effect pigments.
So yes, for automotive especially, we've only used the 45 angle on solids, but I can tell you one thing, because they're milling the pigments finer, they're actually starting to travel. So some OEMs are actually using more angles than they used to do on solid colors. So just be aware of that.
Okay, good. Next question from Emil. Are there goggles or glasses that help to better evaluate colors out in the field?
No. Like if you have sunglasses and you go to look at a color, it's totally going to change how you see that color, because you're changing it based off of what's going through your eye, through the lens to the vehicle. So the best thing is to not have anything on your eyes.
And there are eye tests to take as well, aren't there, just to see if you can physically see, color changes, color difference. Is that accurate?
Yeah, there's a Munsell test that people can take to see if they can actually see the variation in color. We do sell it, or you can just look it up on the website. They do have like a virtual one. The problem is with that one, Corey, you can tell me if I'm wrong, but I think that depends on your monitor and how good your monitor is, right, Corey?
Yeah, most monitors are not calibrated for accurate color. So yeah, that's definitely going to affect the results.
Yeah. Question here from Jose. Do you recommend the booth, using the booth for metallic colors?
Yes, although we recommend the Bica Spectra effect that I mentioned before, which is the one that allows you to rotate the samples to look at them at different angles.
Hey, can you let me, John?
What was that, Ray?
Can you let me, I can show
the
booth?
I'll make you presenter here. Yeah. Changing the presenters to right here. Then while Ray's getting that up, another follow-up from Christopher. Actually, the question is, when you have to approve 100 or more colors per day, how often should you rest your eyes?
Like for math?
Probably between every pair you're evaluating, but you really don't need to do it for long. I think 15, 20 seconds will reset your eyes.
Okay, good.
Can you see my screen?
Not yet. Can't see your screen there. There you
now.
Go. Now. Okay, it's coming over here.
There we are.
All
So
right.
now maybe explain this. Or do you want me to? So what he was talking about before is this is where the samples go, and maybe this helps for me to go back one. So there's a table in here, and you put the two panels in, and there's two holders on each side. And then you have this lever that can change. And basically what you do is you can move it, and your observation angle stays the same, and what's actually changing is the tilt of the table. I mean, I guess your observation angle is not changing, but your illumination angle is staying the same, and your observation angle is changing, and it matches more to what we see with the Bic Mac than on any other way that you can do it. Here you can see like different angles. And here you can see, you know, the 15, the 45, the 75. It all depends on how this table is located. And it gives you sparkle and graininess also.
Nice.
Did I miss anything, Corey?
Nope.
Okay. Good. Thanks for sharing that, Ray.
Yeah.
Another question in here from Suzanne, and I cannot unmute her because she doesn't have a mic available. And that's okay, Suzanne. Her question, we switch between visual evaluation and colorimeter evaluation. So does this information translate well to liquid? Or are liquid evaluation principles and solid evaluation principles very different?
I would.
Want me to read that again? Okay.
Donald, do you know? I don't think they correlate. Do you?
Are we talking about transparent liquids or opaque liquids?
You can't unmute her.
Yeah, I can't unmute her. So why don't you go through both really quickly if you can. And folks, I know we're running out of time. We have a bunch of questions left. We're good to hang on and keep going through questions as long as you want. But if you do have to drop off for another meeting or another appointment, feel free to do so. We'll get you the recording tomorrow morning with our follow-up materials. Sorry to interrupt you.
John, just to let you know, Suzanne responded and said mostly transparent, some opaque.
Okay. Thank you.
Transparent liquids are typically measured with a transmission spectrophotometer, transmission-based spectro, like the LCS that the gentleman discussed earlier. So that's actually looking through the product, shining light through the product, and the detector is on the other side. So the values are going to be different, than they would be for a reflectance-based spectrophotometer that you would use to measure an opaque or a solid.
Okay. Hope that answers your question, Suzanne. Another one from Emil. In order to better evaluate a color match, are there filtered tools or goggles that simulate the light refraction from a tungsten tube, a fluorescent tube, and other artificial light sources out in daylight?
I say no. I mean, I've never heard of anything, but if anyone else has an opinion.
That'd be pretty cool, but yeah, I think you need the actual light source shining on the object in order to see it under the different illuminants.
Yeah.
Okay. Next question here. What is the procedure for calibration? How can we get the booth calibrated once it reaches 2,000 hours?
So there is no calibration procedure. It's basically just checking the bulb to make sure it meets the specifications. So they're checked and they're certified when they're brand new. Typically after so many hundreds or thousands of hours, it's expected that it would, fall outside that range or begin to fall outside that range and should be replaced. but you could always get the booth recertified. I believe we offer that on some of our light booths, recertification, just to check the light sources and make sure they meet the specifications needed. But there's no actual calibration procedure for the light sources.
Yeah. So with that, you can contact our service department or your regional sales manager or inside sales manager. Next question here from Jose. We have special finishes like the stainless brush natural finish. Which instrument do you recommend to evaluate this?
Or color?
Let me unmute you. Jose, I've unmuted you. Are you there, sir?
Yes, thank you. Just for
yes,
color.
we can hear you.
For color, yes.
For color. Okay.
So I think this is a McDonald question again. McDonald. I think he's going to say you want to use a sphere, but
I'm sorry, can you repeat the question?
Sure. Jose, who's on the line with us, has special finishes like the stainless brush natural finish. Which instrument do you recommend to evaluate this?
Yeah, light, right. Light reacts differently with metals than it does with, say, a paint or a plastic. When the specular component hits a paint or a plastic, the reflected gloss is actually white light. But when it hits a metal, it picks up some of that color and carries that color with it in the specular reflection or the gloss. And so you need to encapsulate all of that gloss to get a good color reading, which means you need a specular included sphere to get a good reading on any metals.
Okay, thank you.
All right, you're welcome. You're back on mute here, Jose. There we go. And comment here from Romeo. The Pico Spectra effect is perfect for metallic color evaluation. Thank you, Ray, for describing it. So there you go, Ray.
Thank you.
Yeah, and then let's see. One person wrote in the chat here. Let me find where that went now. Chat. From Kathleen here. Can the reflective or blue light reduction films they put on prescription glasses now affect color? Oh, that's a great question because I wear those.
Ooh.
I don't know this.
Yeah, that is a good question, but I don't know.
Yeah, because I know they're supposed to reduce like screen glare and stuff, but I do wonder. We'll have to do some testing when I'm in the office again, guys.
Yeah, we would have to do some work because honestly, like that falls out of my range of expertise.
Yeah.
If anybody else has a comment who's on, but yeah. We do some work to see.
Oh, great question, Kathleen. And we'll
stumped. I don't think ever.
Say that again, Ray.
I don't think we've ever been stumped on a question.
No, this is we got to send Kathleen some kind of award or something like that. Exactly. So Kathleen, we have a sales meeting or call every Monday morning. So we'll bring that up to see if anyone else that isn't on the call has any ideas. If not, we'll kind of add it to our to-do list and make note. Kathleen just wrote, "Did I win something?" Yeah, maybe. We'll see what we can dig up, in the old marketing closet here for you. So we appreciate that, Kathleen, and we'll go from there. Let's see. Any other questions? I think that answers everybody. Oh, you're welcome, Kathleen. She just said we're great. Okay, one question here from Ronald. How do you quantify visual color appearance due to DOI?
As far as if your DOI is changing, how does that affect your color? Is that the question?
Let me ask him here. Ronald, let me find you and unmute you. There you are. Are you there, sir? You are unmuted. Are you there, Ronald?
Sometimes it takes him a second.
Yeah.
Okay, can you hear me now? Okay.
Now we can. How are you, sir?
Very good, thank you. So,
Good.
and then my question is, yes, we have surfaces with varying degrees of loss, even including surface texture, and I have seen a visual color shift, and we've measured it with our spectrophotometers, but when we try to explain this to our colleagues, I don't know how to correctly communicate that effect. So has anybody else have any suggestion?
So I have a few questions for you. Are you intentionally changing the gloss, or is this a process issue?
It is, in the same panel, we have two different appearance areas. One is a high gloss finish, which is on a chrome tool, like an injection molded tool. And then we add texture, like on a car, like if you were to see a running board. So it's that kind of, not that rough, but similar. So it's a white part, but as it gets to the high gloss finish, the pigmentation looks bluer and darker than it does when it's not ultra high gloss running the 3-angle gloss meter readings.
So yes, of course it's going to change. I mean, is Jim still on? Jim has a little bit more experience with sphere, so technically the sphere would measure those the same material, even though the gloss changed. Maybe that's a way to get around it, but I'll tell you that visually it's completely different. There's no way around it.
Let me take a crack at this one. And we can provide to you an explanation of the different geometries of a spectrophotometer that give you the different answers. But gloss and texture does affect the way that we see color. When you have the same pigmented color but in different textures or different gloss levels, if it's a higher gloss, it's going to be perceived as a darker and more chromatic color. And if it's a lower gloss or a textured type surface, it's going to appear lighter and less chromatic in color. A 45-0 instrument, if you numerically measured one versus the other, would tell you numerically that the higher gloss surface is darker and more chromatic, just like the visual perception. But if you measured them standard versus sample with a sphere, specular included, they will tell you numerically that they are exactly the same because it's the same pigmented color. And so people often will decide on which spectrophotometer to use based on whether they want an answer that relates to the pigmentation of the product or the visual appearance affected by gloss or texture.
Thank you for that.
Does that help?
Yes, it does.
Thank you.
Okay. Great. And if there's anything else you need to, feel free to reach out to any one of us or the regional sales manager, or we can get you in touch with that person as well. So let's see. Okay. I think that looks like we're all clear of questions. We appreciate the lively discussion. And Kathleen, yes, I heard from Sherry, my colleague on the marketing side of things. You will be sent something for your question that stumped us. So congratulations. And with that, you'll receive an email tomorrow morning with the presentation that Corey gave, along with the link to the recording of this, including the discussion during the Q&A. A lot of valuable information there. So you'll get that tomorrow. If you have any questions or need additional assistance, feel free to reach out or just reply to that email. And then also be on the lookout for upcoming big webinars and office hours like today. So with that, thank you very much for your attendance and for the discussion. We appreciate you. Have a great day.
Thank you.
Thanks, guys. See you next time.